Anyway, for this session, attention is all you need. And almost all the large language models are based on this paper called Attention is All You Need. It's such an amazing paper. It contains how large language models can be taught to pay attention to a certain words of input sequence. And almost the same way that a human being can be taught to pay attention to words and things. And it made it possible for something called longer sequence, and it was also able to solve memory issues for previous models. And this paper was a big game changer in AI because today almost all the large language models are based in it. And for our session today, we're going to try do something called building advanced agents with Gemini and Llama Index. Of course, you guys know what Gemini is. I know you play with Gemini here and there. Some of you like other models, but now we have Gemini. There's also Llama Index, which is a framework that can allow you to be able to combine these large language models and other things, like data sources, how to parse them. It gives you like a bunch of tools that you can use around these large language models. So my name is Marvin Ngesa. I am an electrical engineer. I'm very passionate about signal processing and autonomous systems. Currently, I'm working on a very interesting research where you have individual agents in a particular place, like a room, individual agents in a controlled environment. And these agents, they're able to interact with each other, but they're independent. And they have their own individual functions that they have, but they have a goal of maximizing the general functions of the entire kind of network to achieve the biggest goal for the particular network. And now the demo, the one I wanted to show you. So let's see if it works or if I was lying to you here. So this is the demo. So this demo is like something that you can have in like production code. Of course, I have the Python notebook, the Jupyter notebook here, this one here. But usually once you've done your stuff on Jupyter notebook and you want to take it to production, you now convert it into Python files. You can convert, for example, with GenAI, you can convert, you can have an indexer kind of file that goes and index for you your documents and store them in a vector database. Then once it stores it in a vector database, you can also have now a query engine that could go to that vector database and bring you back information. In short, all you have in that notebook, you can now, this one here, you can now convert them into Python files that you can take to production. So that at the end of it, you can be able to avail all this as an API, so that you can have like a web front end that hits an API. Then that API understands your intent or the kind of question you're asking it. Then it goes to the knowledge base. And with guidance from the prompt, it can be able to give you the answer that you want. Or it can be able to trigger all the other agents to do whatever you want to do. Okay, so let's see this demo here of ours. I hope I'm not fast. Am I? Okay. All right, so the query engine is going to go. You can see something here. It's called what? BGE small. This one here. I think it's just an indexer for a sentence transformer. Then I want to tell it to, let's say I'm doing AI. So the first thing it's going to do is to try to understand the kind of event attendee I am. So let me just do AI. Then let me say intermediate. Then let me say any. Let me also say any session. Okay, once I do that, it's going to go load things for DayFest Nairobi, DayFest Lagos, etc. Then I have a bunch of questions here, like this one here. Let me see. Sometimes it works, most of the time it works. Sometimes it can, but let me see. I built this one some few days ago. Okay. So I have this one. Let's see. Did it run? Okay, I just need one. I don't know why it's loading, but I have the questions twice. I'm trying to scroll. Okay. All right, let me enter then. Okay. If you have 2 batches, I think we are safe. Did I get 2 batches? I think it got for AI. Let me ask it again. Let me just do this. Okay. Yeah, so ideally you can be able to ask questions from it, then you get answers from it. And I have a couple of questions that are here on this. Yeah, and also have a notebook here. I'm going to take you through it step by step. I'll have all those questions here. And let me, I don't know, I want to start with the notebook, then I go into explain into, okay. All right. So I have different libraries here, like Llama Index, and I'll tell you what they are. I want to start with the notebook, then I'll take you to the theory part of it. So I'm using Llama Index for embeddings. I also have, I have Hugging Face for embeddings, and then some things from cloud. So of course I'm going to use these two on Google Storage. Then I need this document because I want to pass the data. I want to use it as a parser for my data. Then I'd also want to pass prompt to it, so I have a prompt template. What prompt template does is that it allows me to have my prompt, combine my prompt with my model when I'm using it. And prompt, I'll show you what a prompt is on the slides, don't worry about it. And then also have settings that allows me to attach the LLM to the settings to the LLM that I'm using. Then I also have summary index and vector store index that allows me to index my documents that I'm going to have. Then I have React Agent, and React Agent is going to do reasoning and action on my document and figure which model to use or which agent to use depending on the question that I ask. If I ask a question about DevFest Nairobi, it will go use the tool for DevFest Nairobi or the agent for DevFest Nairobi. Is it a question about DevFest Lagos? It will use the tool for DevFest Lagos. So React on its own have a top level agent that can figure out which tool to use for these different events. Then also have query engine tool, all this. Of course, ID for my Vertex AI. I'm running all this in Vertex AI, as you can see here. And then the first thing I have is, first of all, you'll have a pure Python function that can go to a website, scrap data, and bring it back. But this Python function, you can also convert it into an agent. And what you do is that function, you can have a JSON file, not a JSON, but you can have, how do I call it, a schema that describes what the function does. What is the name of the function? What does it do? When do you need to use it? Yeah. Then once you have this description of the function, including the variables that passes through it, then you can pass all this to a large language model so that when you ask a question, the large language model will follow a prompt, yeah? And then if there's a place where it needs to use an agent, it will use the schema to decide which agent do I need to use. Because this schema has a bunch of agents with a description on when to use them. So this schema guides the large language model on when to use these different tools. A tool like a web scrapper like this one here. So like this web scrapper will just check data, will check what, will scrap and return defs Lego schedule as JSON. Then return dictionary with days as keys and list information as values from the website. So you have day 1, day 2, etc. And here's the link to the schedule. And then I'm using this class called Beautiful Soup. Yeah, fufu. If you want to call it fufu soup. So if I run it, and then once I get the JSON, I realize that it's hard to, how do I call it? It's hard to index a JSON file. Of course, they have their own JSON index and all that. I mean, it's hard to pass a JSON file. So I decided to convert the JSON file into an object. So I convert all this JSON into objects. And then after that, of course, I have a tool yet for handling the FS schedule, so that if I use it, you can be able to go here and give information about the event. You can see this day 1, welcome to FS Legos. Day 2, I think I hadn't updated that one. Day 3, not yet updated. I mean, not days, but time. Okay, let me check this. Yeah, this one was updated, yeah. You can see beautiful multi-agent tenant system, microservice. The last one is this one here. We can actually confirm if this is true on the website, yeah? Just to confirm that is this one true or this thing is hallucinating. You guys have heard about hallucination? Okay. Alright, so if you come here, I think almost the last session is by Korom. Second last one is by Adeya. Okay. So day 1, Friday. Think speaker. I can say the Angie here, yeah? Michael, yeah? I can see building and selling forever. So if I go back, you can see building multi-agent, but the Angie Michael, okay. Okay, alright. I can see session there. Alright, then I can also do the same for Nairobi, just same thing that I've done. And if I go to Nairobi, okay, I can actually ask a question here that what sessions are about web development here. Let me make it bigger so that you can see. Then you can tell me there's a session about empowering this one at scale for Flutter Flow, room 2. You guys can confirm it by the way on the website to just tell me if it's true or not. Then 1 to 50 p.m. building APIs with this one for beyond. Okay, I can also tell you to find me sessions about AI and machine learning. Then if I go deep into it, you can see there's a session here by Gift Ojabulu. On day 1, I'm not sure if it's true, but it's on AI. I think I'm not sure, I know it's true, it's there on the website. Then I can tell it, okay, recommend for me a session of web development. Then to recommend for me this one by confidence, this name, and this other one. Day 1, day 2, exactly about all that. Then also, I have a similar thing, web scrapper for DevFest Nairobi. This is like the link for it. And you can go and extract and pass the agenda from the page source. Almost same thing as the one I had for Lagos, so I won't dive deep into it. But if I go here, you can see DevFest Nairobi 2024, it started at 10 a.m. There's a session around algorithms, DSA, and problem solving by Google Kenya. This session by Femi. Let's check if this is true at around 10 a.m. Let me go to the website just to confirm and see if what we have is true or not. So this is the website for DevFest Nairobi 2024. If I scroll down, I can see Femi is here at 10 a.m. And if I go back here, you can see 10:10. We have Femi on the main wall. Let me expand it again. Yeah, so it's going to like take all of them. Here's budget session, what's new on web, etc. And then, so this will just bring the sessions together. Then once you bring the sessions, you can now convert those JSON into documents. Convert those JSON into Llama Index document objects. And then after that, now you can even index it and show them in a vector database. So here is indexing, etc., etc. So that if I go here, I go to this storage, I can find things to do with Delphus, Nairobi, and Lagos. Like Lagos, this is how the indexes looks like. Of course, you can see what's there. They're just numbers. And here, I'm not using any vector database. I'm just persisting them on the local disk. But of course, you can also use things like ChromaDB, other vector databases that are around there. Okay, so let me go down. So now I can be able to start asking questions like, where is it? I can ask questions like, find me sessions about AI and machine learning. Then it goes and finds the sessions about AI and machine learning. Like this one at the rooftop, exploring autonomous AI by RISPA at the rooftop, yeah? And let's see if this thing is telling us the truth. So rooftop by RISPA, yeah, you can see here. RISPA Joy, rooftop, exploring autonomous AI. Okay. Then now you have these individual agents that can go and bring through that information, but you want to have a major. You have to have a commander at the top, or an orchestrator at the top as an agent that commands all these other agents to do something. I can even tell the two agents that grab for me the information from Delphus Lagos, grab for me information from Delphus Nairobi, and compare the two kind of events. So I have that one here as well. Let me just do it this way. So for example here, I have index for Lagos, index for Nairobi, and index is just the vectors or the numbers from the documents that you have. Then I can now be able to query them. I have query engine, different tools. I have a query engine for Delphus Nairobi, and what it does is that it provides information about Delphus Nairobi 2024 schedule, including sessions, speaker, tracks, timing, etc. I also have one for Lagos that does the same. And then I combine all the tools here, then pass the LLM to a point where if I say, find me sessions about AI machine learning in Delphus Nairobi, it will go and find me that one. This part like here, building by Kai, Wesley, etc. Then I can even tell it now, okay, compare and contrast Delphus Nairobi, Delphus Lagos schedule. Then now I can go pick all those two things, compare the two, then give you a good comparison. You can see here similarities, both events offer a wide range of sessions, what events feature non-speakers, what events offer opportunities, etc., etc. Then it also gives you the difference, and even analysis, and even other considerations, etc. So yeah, that's like the demo I had. But now let me now take you through what all this is and what you can do with all this. Okay, so when you're building this kind of AI, you want to build something that you can take to production. And to do that, you need to have like three key things. One, a universal kind of interface. An interface for your model, so that if someone types, they can interact with your model. And this can be an Angular app, a web app, a Flutter app, or Android app, or whatever. And then beyond that universal interface, you're also going to have something called memory and context. The memory of the chat that you're having, or the one that you stored somewhere on a vector database, but also you need to guide it on how it needs to respond to you. And to guide it, to ask those kind of questions, then you need to have something called a prompt. Even the question that I was asking, for example, the follow-up things that it was giving me, that's a guidance from the prompt, that if you're giving me answers, don't give me answers in any way. This is how to give me the answers. And when you give me the answers also, maybe after giving this answer or recommendation, give this follow-up question to the person. So to do all those ones, you need to have something called context to it. And then of course, behind all this, you have reasoning and planning. And reasoning and planning, you're going to do it with tools like YAPS, reasoning and action. And then behind that one, of course, you pass it through a large language model, like Gemini, for example. So this is like just a general overview of how these systems are built. You have universal interface, you have memory and context, and then reasoning and planning. So it always doesn't have to be a website as a universal interface. It can also be something like this one, where you have a robot that you can talk to and tell it, you know what, take me to the room where people are discussing Gen AI. Then the robot will get the intent, convert them into vectors, go to a vector database like this. The database has a bunch of information, including location maps of the event, details of the room, etc., etc. Then with that, it will know, okay, to go here, to go to this place where you want to go to, from the database, then I need to navigate in this particular way. Then it will navigate and take you to where you want to go to. You can see here the interface is speech. You talk to the robot, it gets your input, and then go to the database, take the answer, and then the feedback it gets, it's given to the control part of the robot, and then the robot moves to wherever it needs to go to. Okay, so in this session, I'm going to take you through Gemini and Gemma, what they are, how to use them, etc., etc. Because the first name I showed you, it's behind it, there's Gemini, and then we also have Llama Index, which is a framework that allows you to combine these different documents, different things around large language models that you can do to build large language models. Then I'm going to show you how to build Agentic RAG with the React I'm going to talk to you about, and even how to write effective prompts. And all in all, how to build agentic workflow with React. How do you have like planning pattern, etc. But React is not the only way to build agentic workflow. There are also other ways, like tool use, tool functions that someone talked about. There's multi-agents by Crew AI that someone also said that they know. So there are different agentic patterns that you can use. But I want to focus more on planning and also show you the others that are existing. So for the guys who are coming up for the very first time, there's something called AI. Of course, all of you know it. There's something called machine learning. There's something called deep learning. AI is training a machine to behave almost like a human being. And what that means is a human being can see, can sense, can feel, and all that. So if you can teach a machine or can write a program that can sense the environment, reason from the environment, act from it, and even adapt, then that's an AI. And this AI, if you can give it more data over time, and then if performance increases or improves, that is machine learning. But if you give it more data, more unstructured data, you give it videos, you give it images, you give it audio, you're not just giving it like tables and columns, you're giving it unstructured data. And you have like layers and layers and layers of neurons, then that's deep learning. Deep learning is part of machine learning under AI umbrella. And you could have like the values of X, like this one here. The simplest way to know what machine learning is, so you have values of X and values of Y. And if you see those values of X, what do you think is the relationship? For 1, you have 7. For 2, you have 14. For 3,
21.
For 10,
For 10, 70.
for 20.
140.
What's the relationship?
7 times 1.
Yeah.
7 times 2.
Yeah, so you have this function here, y is equal to 7x. But you think x is always 7? Yeah? Is it always 7? If you go test this in a notebook, do you think you get 7? What do you get? Why? Yeah. It's true you won't get 7 because maybe you don't have like enough data to prove that it's that actually the relationship between x and y is 7. You can get maybe 6.8, 6.5, etc., etc. But if you give it like more data that is consistent over time, it will know, okay, it should be 7, y is equal to 7x. So if you have this algorithm and you give it like more data, both x and y, over time, you'll have like a good relationship that maps values of x to values of y. That's machine learning under AI. Of course, if you see that equation the way it behaves, you have like y is equal to mx. It's like high school maths, yeah? Is it high school?
Yeah.
And here you have 7 here you have 0, yeah? This one is just in machine learning, but this one is mx plus c, yeah? Is equal to y. And this is like the simplest equation. In this equation, if you give it inputs here, like values of x here, it does processing. It multiplies that input by 7 and adds 0 to y. That's processing, yeah? Addition, subtraction, division, multiplication. That's processing. And with that processing, if you give it any input, you get an output. Give values of x, you get values of y. And because this thing, if you give it input, you get output. That's the same way that also our neurons in the brain works. If you give it some inputs, it does processing, give you outputs. And that we can call that linear unit to be a neuron. But that one is just a linear unit. You can say, okay, this linear unit behaves like the neuron in the brain. Let's call it a neuron. And of course, you're going to have training and losses in it. Here you can see what you have. You have like true values. The black one is the predicted value. Then the red one is a true value, the ground truth. You figure the difference, then that difference will be your loss. Then figure out how to reduce that loss, or how to minimize the loss. If you minimize the loss, then you're doing machine learning. You're doing ML, because you're able to do prediction, figure the loss, and then your key goal is to find ways to reduce that loss or minimize the loss. Okay. And we've been having, of course, for a long time, we'll be having predictive model or predictive ML or AI, to a point where if I ask you the value of 10, you tell me it's, in that equation, tell me it's 70, yeah? If I ask you 20, you tell me like it's 140. It's kind of, you're doing predictive kind of AI or ML. But there's also generative models where you can have unstructured data together, where you can model the frequency distribution of the data that you have, be it images, be it videos, or wherever. You can just model the frequency distribution of that data. I know frequency distribution is a big term, but you can map those values of x to values of y, and just model that distribution, how it looks like, to a point where you can be able to detect complex patterns in these different data sources, and even be able to produce new content like images, video, audio, and data. And this one is not for someone who's going to build, let's say, it's not for someone doing applied AI. I'm on someone doing core AI. So if you're doing applied AI, don't worry, your section will come. Don't worry about all this one. Your section now, you can apply this one will come. So, yes, so that's the part for Gen AI. And of course, deep learning, I've told you, is under ML, is under AI. I'm just trying to move you from what AI is all the way to large language models or deep learning. And Gen AI, of course, is a subset of deep learning. Okay, let's go to the LLMs, yeah? But before that, probably you're wondering what Gen AI is. I've told you, of course, it's kind of AI that can produce new content, like images, like text, like audio, data. And all this depends on the distribution, frequency distribution of the data that it was trained on. And probably you've heard about LLMs, large language models. I know if you're building web app or you're building Android, at least you've heard about large language models. And who knows the difference between ChatGPT and GPT? Yeah? Eh? What's the difference between GPT and ChatGPT? Yeah? There's ChatGPT, yeah? But there's GPT. What's the difference?
GPT is a foundational model, while ChatGPT is an interface where you interact with the large language model, which is GPT.
Okay, yeah, I think that's true. But I wanted you to answer in the context of what's here. Yeah.
So I think GPT talks about generative pre-trained transformers, which talks about like the theoretical foundations of what's actually going on, whilst ChatGPT is a product of that theoretical foundation.
Yeah, so all of you are correct, but GPT is a large language model, yeah? But ChatGPT is an interface for the large language model. So if you go to talk to ChatGPT, there's an interface, picture intent, but behind it, there's a large language model, yeah? And these large language models, you'd say, it's just a neural network. Large language models are neural network that are trained on large data sets. I've told you what a neuron is. If you combine these neurons together, you have a neural network. And if you have a neural network that's trained on a large data set, you're going to have a large language model. And I'm talking about trillions of text, trillions of images, trillions of audio and video. And again, all you're trying to do is to model the frequency distribution of that data that you're training it on. And this way, it can be able to detect complex patterns from these different data sources, so that if you give it an input, for example, it's raining cats, the model will predict that the next word is going to be dogs, yeah? It's going to be dogs because in that frequency distribution, most words are in that particular format. If most words are, it's raining cats and dogs, it's not it's raining cats and what? And hyenas, or cats and pigeons. Most words there, it's raining cats and dogs. And this is from the frequency distribution. So you can say that these large language models, they're just maybe some kind of sophisticated kind of autocomplete. Okay, and the large in it is that you have trillions of tokens, parameters. You guys know what parameter is? Yeah? What is it? No, in terms of large language model. In the context of a large language model. Yeah? Do you guys know what it is? We have seen it. We have seen it in the previous slides. Yeah? Parameters. You've heard about 17 trillion. Yeah? Llama 13B. What are they? Yeah?
Is it the weight of the data set? Or okay. I see.
Yeah, so if they talk about 13B parameters, that's 7 there. Those weights, the gradients in all these large language models. Those are the parameters. So 340B, 13B, and also large. So that one we just had one parameter, yeah? Just one. But now imagine 13 billion parameters. Billion, B for billion parameters. Or 1.7 trillion parameters. Imagine. The other equation was just one parameter. Okay, so yeah, and we have different kind of models. We have closed models, we have open source, we have fully open model, closed models like Gemini, and closed means that you can't run these models locally, you have no access to the model's internals, and then you have limit fine-tuning capabilities. These are closed model, like Cloud, for example, Gemini, ChatGPT, for example. Then also, you have open weights models. These open weights include Mistral, Llama, Gemma. You guys have heard about Gemma? Yeah, Gemma or Gemma. And you don't necessarily have access to the training data or code. Of course, it has some few scientific reproducibility. Then also you have like fully open models, like Bloom, etc. So let me just go and jump into Gemma and Gemini fundamentals. And you'd say Gemma is this family of lightweight, state-of-art, open large language models. Now you know what large language models are. Built from the same research and technology used to create Gemini models. That's what Gemma is. Okay. Gemma. Okay. All right. All right. Now, I want to take you step by step into all this so that you understand nicely. Someone is asking, what are these weights? What are these parameters, yeah? Let me take you step by step. Imagine you have that list, X with those values, yeah? You have Y with all these values, yeah? And you want to figure out the relationship between the X to the Y, yeah? So if you draw your equation, all this, or if you figure out the relationship, you realize that what if for every value of X, to get a value of Y, you need to multiply by a particular number, yeah? And that number is 7. If I have 10, I multiply by 7. If I have whatever, that number is 7. That number is kind of constant, yeah? That 7 is the parameter. It's the weight here. It's the weight. If you have Y is equal to mx, m is a gradient for our equation. So that gradient is a parameter, yeah? Here we just have one parameter. But in deep learning, you're going to have like more and more parameters, millions of parameters. In Gen AI, you're going to have billions of parameters. Like today, what's the parameter for Gemini? What about Llama? 13B. What about Llama 13B? Or 7B, yeah? Or Gemini or Gemma 7B or 13B. So those are the parameters. And these parameters, of course, there are different ways in which you can use them you can tweak them and adjust those weights and biases to a point where you always have like the best sets of weights and the best sets of gradients that always give you the best sets of weights that give you the correct values of y. Yeah. So your goal as a machine learning engineer is to find ways in which you have the best sets of weights that gives you the best answers, or the best sets of parameters that gives you the correct answers. Okay. So let me go here again. So that's Gemma, and Gemma has like a different family. You have Gemma, code Gemma, recurrent Gemma, polygemma, Gemma 2, the bunch of them, even Gemma scope. And all of them have like different functionalities. For example, code Gemma, it's a specialized kind of model that is optimized for code generation. If you want like a model for code generation, then it's code Gemma. Then we also have recurrent Gemma. That is kind of a specialized kind of model or Gemma model for handling sequential kind of data. And you can always use it for things like time series data or pattern recognition. And it uses things like RNNs. I've heard about RNNs, recurrent neural networks, RNNs and LSTMs, but don't worry about those. But you can use it in text, in speech-to-text applications, or in text generation, and even time series forecasting. Then, which one else do we have here? You also have things like polygemma, which is it's kind of a model that combines both multimodal learning, combines language and vision tasks together, and it's able to handle tasks that require both text understanding and image understanding. So now, the demo that I showed you, it had an agent that goes to a website, grabs the data, bring it back, goes to Defest website, yeah, Lagos. Also another agent that can go to Defest Nairobi website and bring it back. If you're using Gemma, you could try use polygemma to go to Twitter, yeah, Twitter to go to the hashtag Defest 2024, Defest Lagos, yeah, grab all those data, both text and images, and then index them. And then you can now be able to ask questions from what you have on Twitter in relation to Defest Lagos. Beyond that, you can also even have another agent that can go to, let's say, OneDrive somewhere or Google Photos, and then get all this video and understand the video part of it or the images part of it, understands the text that are on Twitter, understands the content that is on the web page for Defest Nairobi, understands the content that's on the Defest for Defest Nairobi, Defest Nairobi and Defest Lagos. And then with all these agents, with one orchestrator, you can tell it, now write for me a blog or a report about Defest Lagos, or about Defest in Africa, or about Defest Lagos, or about both Defest Lagos and Defest Nairobi. And also, create for me like images for the same. Then you can have like a proper blog about the two events with maybe some images from it. Is that exciting? Eh? Yeah. So yeah, you have a bunch of them, called Gemma, recurrent Gemma. Let me not go into them. Of course, you can access Gemma in Kaggle. How many of you uses Kaggle? Ah, nice. You can access Gemma in Kaggle. Just go to Kaggle, search for Gemma, choose the model from the variant that you need, confirm access, request, and then you can now download it and be able to use it. Gemma is also in Vertex AI. The tool I was showing you was actually Vertex AI, where I was showing you the demo. So you can go to Vertex AI, and Vertex AI is ideally a managed machine learning platform which simplifies the process of building, deploying, and scaling AI models. And you can just go, actually you can access all of them today and run them locally with things like Llama, for example. So if you go to Vertex AI, the first thing you do is that you'd go to Model Garden, and then once you click Model Garden, you'll be able to see these different foundational models. Someone talked about foundational models. You'll now be able to see models from Cloud, models from Imagen, Gemma, Polygemma, the different ones. And then you can select, for example, here I'm selecting like Gemma 2 on the other side. Then once you select it, you can now deploy the model. And once you click deploy, there's just a few things here that you fill, like resource ID, model name, endpoint name, region, machine spec, etc. Then it will deploy and send you an email. To your Gmail. Then beyond that, you'll now have an endpoint or a model. If you go to model registry here, you'll be able to find an endpoint with all this model that you can use, and even test it. You can have a JSON with your question, yeah, and other parameters. Then if you send this JSON to the endpoint, it will now be able to get answers and bring it back to you. Yeah. And by the way, today, I think you can get free credits for research and development for Gemma. If you go to, I think this link here, I'll tweet the link so that you can check it out and play with it. Okay. Then the other thing was RAG. This is how the RAG works. The guys looking for RAG, this is how it works. Yeah. You have documents. In our case, you have JSON or Llama Index documents that we've already gotten from the different websites, all the different sources. These documents, you load them with document loaders. Once you load them, you can split them into small chunks. If you're using Llama Index, you'll call them chunks, small pieces, yeah? If you're using LangChains, you'll call them chunks. If you're using Llama Index, you'll call them nodes, into small nodes. Then these nodes, you then convert them into numbers, into embeddings or vectors. You guys know what a vector is? You guys know what's a tensor? What is a tensor? Yeah. What is a tensor? Yeah. Okay. That almost close. So if you have what's a one-dimensional array? Yeah? What is a one-dimensional array? How do you call it? Like a list, yeah? Yeah. What is a two-dimensional array? A matrix, yeah? A three-dimensional array? Okay. An n-dimensional array is called a tensor. That's why they flow in that equation. All right. Then you have vectors here. I mean, you have those different embeddings. Store them in a vector database here. And then you can now ask a question. Then you have, you convert your question into embeddings, numbers. It does a search here, like semantic search. Then there's some ranker that you can use to rank your questions. Then you pass it through an LLM and then get your answer, like I was showing you on the answers. And beyond that, there's also prompts. I think my time is over. You can also decide to write like prompts, like this one here, a prompt that guides how you get these answers, yeah? I wish I had more time, I'll show you. But with a prompt, you can be able to define the task of your model, define the tone. Which tone should it use when it responds to you, yeah? Is it the tone for Nolfis? Is it the tone for playful kind of thing? Which app are you building? Depending on the app you're building, you can define the tone. Is it an app for children? Is it an app for medicine? Is it an app for dev first? Should it be eager to give you an answer? Should it be eager? All those you can define on your app for it to respond. Then you can also give it examples on how to do that. Plus a bunch of things. And I have an example there. I also have the example on GitHub. I'll tweet the link on Twitter. And then, of course, I talked about agentic workflow. I'll show you this one for planning. But the others like multi-agent pattern. This one for Crew AI, which has like different agents and they run with you can use it with Crew AI. You also have tool use where you have like different tools. These different tools have schemas that defines the tools. The schema is just a list with dictionaries. The dictionaries have what the name of the tool is, when to use it, how to use it, etc. And then without anything like React, you can just use a tool with Gemini. This tool can also be called function calling. So you have function calling in Gemini, function calling in Cloud, function calling in Gemma, in all these different ones. So these are just some common common agentic patterns. The one I implemented was this one here. But you're not just limited to this one. This one is React. You can also try these other ones depending on your use case. So I have this code on GitHub. You can just follow me on Twitter here. Then I'll send you the link to the slides and also the links to